Good afternoon. I am Dr. N. Zulfarin, Associate Professor, Department of Chemistry, Mahendra Engineering College. So today I am going to discuss the topic conditioning methods. So what is conditioning methods means conversion of hard water into soft water. So before moving to the conditioning methods of water, let me introduce something about water. So water is the most important compound for the existence of human beings, plants and animals. So 80% of the earth's surface is occupied by water. So main sources of water are classified into two, that is natural sources and artificial sources. Few examples are rain, rivers and lakes comes under natural sources of water. Now artificial sources of water is wells and springs. Okay. So next, so among the above sources, that is natural and artificial, rainwater is the purest form of water, but it is very difficult to collect the rainwater which is available in pure form. So we are going for the method of underground water, that is normally used for domestic and industrial purpose. Such water must be free from undesirable impurities. So the process of removing all the types of impurities from water and making it fit for the domestic and industrial purpose is called water technology or water treatment. So before treating the water, we should know some natural and artificial impurities that participated in water. So hard water. So before moving to the conditioning method, we must know what is hard water and what is soft water. So both the water is used for domestic purpose, that is hard water means the water used for especially domestic purpose, that is for planting trees and washing purpose, bathing purpose, etc. So that contains calcium and magnesium salts, that is hardness causing ion. Now soft water. So soft water is used only for drinking purpose, that is absence of calcium and magnesium ions but presence of chlorine ions. So chlorine is added here to kill the germs and bacteria present in water. So now entering into the method softening or conditioning method. So so far we have seen what is hard water, what is soft water, then what is the purpose of treating the water. So first method is in conditioning methods, it is classified into two, external conditioning and internal conditioning. So external conditioning. So external conditioning is again classified into two types, demineralization or ion exchange process. Second method is zeolite process. It involves, so external conditioning method involves the removal of hardness producing salts from the water before feeding into the boiler. Okay. So first one is demineralization or ion exchange process. See, by the name itself, ion exchange, exchange of ions here takes place. So demineralization means here removal of all the minerals present in the water. So the process removes almost all the ions, both anions and cations present in the water. That is called as ion exchange or demineralization process. So now we are going to see what is demineralization process. It is carried out using ion exchange resins, which are long chain, cross linked and insoluble organic polymers. That means it has a straight and long chain with have branched chains and insoluble organic polymer with a microporous structure. The functional groups are attached to the chains that are responsible for the ion exchanging properties. So here we are adding two type of ions, that is cation exchanger resins and anion exchanger resins. So cation exchange resin is also called as cation exchanger, anion exchanger resins is also called as anion exchanger. So from the name itself, you know, here there is a presence of cation and anion, here there is a presence of anions. So cation exchanges. So resins containing acid as a functional group, especially the acidic functional groups like COOH and SO3H, are capable of exchanging the H plus ions with other cations of hard water. So it is cation exchanger are generally represented as RH2. So R indicates any of the functional group, alkyl, aryl, whatever may be. So here are the few examples of cation exchanger resins, that is sulfonated coals and sulfonated polystyrene. So next one is anion exchanges. So resins that containing the functional groups like NH2 and OH that are capable of exchanging their ions with other anions of hard water. So anion exchanger resins are represented as ROH2. So cation exchangers are represented as RH2, anions are represented as ROH2. So few examples of anion exchanges are cross-linked quaternary ammonium salts, then urea formaldehyde resin. what is the process here carried out? So far we have seen what is the conditioning method or softening method. So next, what are the types included here, that is internal and external. Then in external we have seen demineralization. So in that demineralization, what is cation exchangers and anion exchanger. Now what is the process taking place here? So when we add hard water, that undergoes softening method. So the process carried out here is the hard water first pass through a cation exchanger column which absorbs all the cations like calcium, magnesium, sodium and potassium present in hard water. So few reactions are, that is RH2, representation of cation exchanger, then addition of calcium chloride or magnesium sulfate. So calcium and magnesium ions are responsible for hardness causing ions in hard water. So that undergoes reaction to give RCA plus HCl. If it is magnesium sulfate, again the hardness causing ion magnesium, so RMg plus H2O. So now the cation that is free from water. Now we have removed the cations that is present in the water. The water is free from cations, that is passed through anion exchange column which absorbs all the ions, that is especially ions, anions like chlorine, sulfate, etc. present in the water. Now the water is free from both the ions, that is cations and anions. So few examples of anion exchanger resins, it undergoes reaction with ROH2 plus HCl, reacts to give RCl2 plus H2O. So next process is, here the diagram indicates the removal of cation exchanger and anion exchangers. First the raw water is passed through the cation exchanger, then all the cations present in that is removed, then it passed through the anion exchanger, then all the anions present in that is removed. Finally we are getting the deionized water or demineralized water that is free from all the cations and anions. See, after doing the process we are going for the regeneration process, that is addition of acid for a regeneration of cation exchanger and addition of a base for anion exchanger. So the acid here we are using it dilute HCl. So next one, the base here we are using is dilute NaOH. So the water coming out from anion exchanger is completely free from cations and anions. So as we said, that water is known as demineralized water or deionized water. So now the regeneration process. See, the regeneration process, whatever the anions and cations we have added during this process, that can be regenerated by the addition of a acid and a base. So here the cation exchanger resins, that is exhaust, it can be regenerated by passing a solution of dilute HCl or dilute H2SO4 acid. So HCl or H2SO4 acid. So that undergoes reaction with hardness causing ion RCA plus HCl, reacts to give the cation exchanger RH2 plus removal of calcium chloride. So similar to that RNA salt plus HCl undergoes reaction to give RH2, again the cation exchanger plus NaCl. Similarly, when the anion exchanger resin is exhaust, it can be regenerated by passing a solution of dilute NaOH, that is base. So that undergoes reaction with RCl2 plus NaOH, reacts to give ROH2, that is anion exchanger resin with the removal of salt NaCl. So what are the advantages and disadvantages of the process? So advantages is highly acidic or alkaline water can be treated by this process. So the water obtained by the process will have very low hardness, nearly 2 ppm. Disadvantages: water containing turbidity Fe, Mn, and that is ions like Fe and Mn cannot be treated because the turbidity reduces the output of Fe and M, form stable compound with the resins. So that's all. Thank you.